small piston of a hydraulic lift, it's over here, has a radius of 5 centimeters, and its large piston has a radius of 25 centimeters. A 30 Newton force is applied to the small piston. What is the weight of the load that can be lifted by the large piston? For a contained fluid, the pressure within a system at equal heights is constant. Right? The pressure here is equal to the pressure here. And Pascal's principle, any change in pressure caused by pushing this guy down will have the exact same change in pressure anywhere else in the fluid, assuming it's an incompressible fluid, which is what we'll assume here. So in this case, we're at the same height, the pressures are the same, so P1 is equal to P2, or P in is equal to P out, either one. So here we call that 2, and this is 1. So the definition of pressure is force per unit area. So F1 over A1 equals F2 over A2. We take our equation from the previous slide and substitute in our values for the area. Well, what did we say? It's circular? Yep, we said radius, so you assume that's a circle. So the area of 1 is pi r1 squared, area of 2, pi r2 squared. Pi's cancel out, and we're left with this expression here. We rearrange for F2 by multiplying both sides by r2 squared. And now we just substitute in our numbers. We have 30 newtons being applied here, the force. And what we're having is the force won't be the same over here, the change in force, but Pascal says the change in pressure will be the same. So that's what allowed us to use these equations. So now we put in 30 newtons, which is the applied force on the left side. We have our r squared, and once again we'll make an exception here. We'll leave centimeters as the units for radius because we're working with a ratio and they're canceling out anyway. So if we converted it to meters, well, you'd get the same thing. So we get the force applied over here, the out force, is going to be 750 newtons. So this force here can support a load of 750 newtons just by starting with 30 newtons. That's a force that's 25 times. 25 times 30 is 750 newtons. So what we do is we ratio the out force over the in force and we get 25. That's the mechanical advantage. The mechanical advantage of this system is 25. Why? Because that's the factor that the force increases by.